Welcome back, Math Marvels. This is our final video for Algebra 1. We're up to lesson 102, and in this lesson we're going to relate geometric sequences and exponential functions. So we're going to work through these. In this lesson, here's our criteria for success. We're going to identify the geometric sequence by looking at a graph. We're going to identify the common ratio of the sequence, and we're going to use that common ratio and the initial value to form an explicit rule. So let's look at relating our geometric sequence to our exponential function. And again, these should be two expressions that will be equivalent to each other. So we already know that geometric sequence is equivalent to the exponential function as long as the domains are positive integers. For the exponential function, we have this form f of n is equal to a times b to the nth power, where a is that initial value when x is equal to 0. So 0a, I'm going to put that in there. And b is our common ratio. And we know the nth is a degree. Now, in our other form, we have f of n is equal to f when x is equal to 1. So that's where there's a difference here. When x is 1, what is f of 1? So then we're looking for that number. And then this is times our ratio and n minus 1. So that's the difference here. Notice it's so subtle that it can be very easy to miss. Whereas for exponential function, we're looking for when x is 0, what is a? And here in our explicit rule, we're looking for what is f of 1? And then the same thing, we have the common ratio. So the rest of it, the ratio is the same. And then here it is n minus 1. So let's see if that makes a difference. All right, let's look at our first model problem. And here I'm trying to make an explicit rule for the sequence of bounce heights on the chart. And that means I need two values. I'm going to need that common ratio r, and I'm also going to need f1. And that is the when I have x is 1, what is the y value? That's the one I'm going to look for. So that one's the easiest one to get. Just looking at my chart, I can just find it right here. It's 100. So that's easy. 100. To find the r, the ratio, I'm going to have to go into either my table or my chart, and I'm going to create a ratio of each pair. So again, if I'm looking at these two numbers, my ratio is this divided by this. So 80 divided by 100, and I would get 0.8. Or if I wanted the next set, it would be 64 divided by 80. And if you take out your calculators, you'll also get 0.8. Or 51.2 divided by 64, and again, you get 0.8. So that means your r is a constant ratio of 0.8. And that makes sense. It just means that instead of your bounces getting bigger, they're getting smaller each time by multiplying it by a number less than 1. We're multiplying it by 0.8. So it's 80% of the original bounce. So to write my sequence in an explicit rule, f of n, I'm just going to take f of 1 times r n minus 1. Or my rule would be f of n is equal to 100 times 0.8 to the n minus 1, where n is the bounce number and f of n is the bounce height. So hit pause and jot this down into your notes. And again, this is for an explicit rule, so you do need the r and the f of n. But what if instead of an explicit rule, you want to use the exponential? And that means you're expressing it as f of n is equal to ab to the nth. Now, a is, again, not the same as f of 1. A is the value you get when your x is 0. So 0 and a. That's the one we're going to look for. Now, that is the one that we don't have here. So what if I want the exponential function ab to the x? I do know my common ratio. I still have that 0.8, and it will still be to the nth. But what I won't have is that value for a, because that's not the same as f of 1. So that I do need to figure out. Since I know the common ratio is 0.8, each time it's being multiplied by 0.8. What if I want to go in the other direction? So instead of multiplying a number by 0.8, I'm going to try and figure it out in the opposite direction. So this is how I'm going to set it up. I know that it's going to end up being some 100 over a, whatever that a value has a ratio of 0.8. To find that number, I'm just going to put a 1 under here and cross multiply. So I have 100 is equal to 0.88. And then I'm just going to divide both sides by 0.8. And that way I'm going to be left with 125 is equal to a. Now I can rewrite this in an exponential form. 125 times the rate of 0.8 to the nth. All right, to whatever number we're looking for, the nth term. All right, so hit pause and jot this down. Again, this is only if they're asking for exponential, but in reality, most of our questions for today are going to ask for this in the explicit rule. I just wanted you to see the slight differences between both. Let's do our final guided practice. Here you have another series. The number of passengers that ride a subway every hour, n, is represented by the following table. Hit pause and write an explicit rule for this sequence. Let's write our explicit rule. We need the value of f1 as well as r. On our table, we can see f1 would just be 1,000. And if you did your division and set up your ratios correctly, you will get r is equal to 1.5. And that means you would just do this division and you would have gotten 1.5. And if you had done the next set of numbers, you would also get 1.5. So given this, we can now write our explicit rule by just substituting. And I'm just going to put parentheses around this. And that is it. That was our goal for today, to be able to calculate the common ratio of a sequence and then use the common ratio and initial value to form an explicit rule. I hope you found this super helpful. It's been a pleasure working with you the entire year. You are officially done with all of Algebra 1 for Math mini lessons. Take your notes, use your criteria for success for feedback, be patient, and you're going to have a great year. You're going to do great things in mathematics. I hope you had as wonderful a time as I did. I will see you next year, Math Marvels. Be well.